Hello everyone, this is Mr. Barnett, and in this video I want to introduce you to the first math challenge of the year. I'm calling that Challenge A, and that is the challenge of the demographer. If you don't know what that word means, don't worry, I'm going to explain it in this video. The topic which this covers, in case you're curious from the syllabus, is mathematical models. So let's dive right in and think about what does that mean, mathematical models. Well, let me introduce what I mean by modeling in mathematics. Math is often used to study quantities that change. So here's a nice example that I got from the IB Math Studies textbook. Here's a picture, and we see what's changing here. We see that over time, the man who's jumping from the top of this rock, his position is changing. His height above the water is changing. And so we might want to use math to study this man's path and see maybe is he going to land safely. So one thing we can do is we can get some data from this picture, right? We could time him. We could look at the seconds and look at his height after 0 seconds, 1 second, 4 seconds. From that data, we could move towards perhaps an equation and come up with a formula here, right? If we said t is the time, h is the height in meters, well, we could say the height is equal to negative 1.97 multiplied by the square of time minus 20.25. And we'll see a little bit where these equations come from. I'm just trying to introduce the concept. And then from there, we can take that equation, we could even put it onto a graph. And so now we've taken something very concrete, which is the man jumping off the rock, and turned it into something more abstract, which is just a bunch of points on a grid, and then we could use that to kind of figure out, well, how high is he after 2 seconds? Or how long does it take him to reach the water? Those are all questions we can answer using the equation and the graph, and they're questions like the ones you're going to use in this project. So let's talk a little more about this project. This project is about population and making models of populations. If you think about something that changes all the time, it's population, right? That could be the number of people in China. It could be the number of people in a city like Paris. It could be the number of elephants in Africa, etc., 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 right? A population is just a group of individuals, and the numbers or size of populations change constantly. Well, why might we want to use math to study changing populations? Well, we could study them in order to analyze the effects of past developments. So we might see that the population of people in China increased all of a sudden, and we might think, what could explain that? We might want to describe the current state of things. So if we were looking at people in Paris, we might say, well, right now Paris is the third largest city in the world, or something like that. And finally, maybe most importantly, we can make predictions about the future. So if we're thinking about elephants in Africa, we might say, in 10 years, I'm worried that elephants are going to be extinct. Or in 10 years, there will be too many elephants, right? Using math and models for population, we can do all of these three things. So just to show you an example, right? Here is Manhattan in New York City. This is the 1800s. Here's the 1900s. And here's the 2000s, right? We see, just by looking at pictures, a huge change. What if we can use math to describe that change and maybe think about what will Manhattan look like 100 years from now? That's what this project is about. So here it is, the Demographer Challenge. First, let me define the term. A demographer is a person who studies changes in numbers of births, marriages, deaths, etc., in an area over a period of time. Basically, someone who tracks population. And so for the first unit of this course about mathematical models, you're going to be a demographer for a population of your choosing. So you're going to choose a population that interests you. It could be the population of your hometown or your home country or an animal that you like. There's your choice, and I'll give you some resources to find populations. Find the size of that population at 3 or more times in history, right? Maybe for Manhattan, that's 1800, 1900, and 2000. And then use mathematical models to study how that population is changing. And actually, as we continue through this challenge, you're going to learn mathematical models that are going to help you make predictions and describe changes. And then the final project of this challenge is going to be a report which you submit to some relevant international organization. So if you're studying human population, you might submit something to the UN. If it's animal population, it might be to the World Wildlife Federation. We're going to talk more about the final project, but just wanting to emphasize to you, you're doing something that is based on real data and I hope has a real application at the end of all your hard work. So here's what I'm going to ask you to do now. You won't see a video from me for every lesson, but you will kind of when I'm introducing a new project or something I want you to do. Here are the things to do. Using the links provided below on this document, identify the population that you wish to study. Collect the size of that population on at least 3 dates in history over a period of at least 10 years. And you're going to record that information in the application section below, but you want the population on one date, another date, and then the most recent date possible. You're going to review your choice of population with your teacher, who will approve your choice or give you further suggestions. So if I think you have a good start, I'll say perfect, go for it. If I think you can maybe improve something, then you'll have the chance to go back and improve that. And then there's a self-assessment survey at the end of this module. So with that, go for it, and please let me know what questions you have. I really look forward to seeing the work you produce.